Okay, let's unpack this. If you're maybe prepping for a meeting, trying to get your head around what actually makes cloud management efficient, or, you just want the ultimate cheat sheet on how smart organizations stop wasting millions on tech, then this deep dive is absolutely for you. Today, we are focusing on one of the most critical and, frankly, one of the most challenging parts of the entire framework. It's the domain called Optimize Usage and Cost. And this is not just about turning things off, it's a really deep architectural and financial strategy.
It is, yeah. Our mission for you today is to distill the core actions organizations take to make sure their entire technology estate, cloud,
Yeah.
data centers, software, is not just working, but that it's profoundly efficient. We're trying to look past the high-level goals and really get into the mechanisms they use to design better systems, eliminate waste continuously, and lock in the best possible rates for everything they use.
Right. And the source material drives this point home right from the very beginning. The optimization actions, they're designed to enable value across the entire technology estate. I mean, while the cloud is obviously the main driver for FinOps, this domain is explicitly designed to handle those other intersecting scopes.
Exactly.
Your legacy data center stuff, that licensed software you bought 10 years ago, even SaaS contracts. It's a really holistic view of efficiency.
That holistic view is absolutely essential. Let's define what optimization even means in this context, because it's so much more than just cutting costs. It's really a commitment to continuous action all the time throughout the entire life cycle of your technology. The goal is pretty simple. Introduce and then relentlessly improve both the efficiency and the cost effectiveness of their design choices and how they deploy things. It just never stops.
I think what really defines this domain and what actually surprised me in the source material is that efficiency isn't just measured in dollars anymore.
Absolutely. That's the classic narrow view.
Just the money.
Just the money. But these sources, they highlight a much broader, more contemporary perspective. Efficiency is measured through a kind of triple bottom line now. Yes, monetary cost is paramount, of course it is. But organizations are now systematically tracking efficiency through carbon usage.
Wow.
So directly tying tech decisions to big corporate sustainability goals. And third, they track the traditional IT operational efficiency measures, things like response time, uptime, utilization rates.
That immediately raises the stakes, doesn't it? If you suddenly have to manage cost, carbon, and performance, you're introducing this fascinating tension into every single architectural decision.
You do. And to manage that tension, the domain's actions are really focused on three specific interconnected elements. First, we have to optimize the types of resources we're using. Are we using the right cloud service, the right instance family? Then we have to optimize the amounts of resources. So are we right-sized? Are we scaling effectively? And then maybe the most strategic part, we optimize the rates we pay for those resources.
So it's the how much and
how much you pay. You have to get all three right.
it's like managing your house, right? You can use less water, which is the amount. You can switch to energy-efficient appliances, that's the type, or you can call the utility company and try to negotiate a better contract. That's the rate. You have to do all three at the same time to really maximize savings.
That is a perfect analogy.
Yeah.
It really is. And because you have to manage all three, optimizing usage, well, it's not something that can happen in a silo.
Precisely. Which brings us right back to that core FinOps principle that everyone takes ownership for their technology usage, and crucially, that teams need to collaborate.
This handoff is where I think most organizations fall down. It forces us to ask, who actually owns what here?
That collaboration piece is just the bedrock of this whole domain, because optimization requires this continuous action from engineering, from finance, and from procurement groups. We really need to distinguish clearly between, let's say, technical ownership and strategic financial ownership. Okay, so let's start with the technical owners. This is where the engineering groups live and breathe. They're the ones deciding what tech to use and how much of it to run.
Correct. The engineering groups hold that technical responsibility. They are on the hook for architecting, designing, building, operating, and this is the critical part, continuously optimizing their applications for cost-effective operation. It isn't just a day-one job. It's a constant, ongoing refactoring exercise.
And the list of things they have to do is huge. It's things like architecting specifically for cloud elasticity, making sure you have effective resource utilization through right-sizing and auto-scaling, and reacting quickly when new, more efficient cloud services come out. But this isn't only a cloud discussion, is it?
Not at all. Because they also own the licensed software footprint. They have to ensure effective and appropriate use of licensed and SaaS models. If they decommission a server, they have to remember to free up the associated Oracle license or shut down that enterprise SaaS seat that nobody's used for 6 months. Cost-effective operation is a holistic mandate for engineers.
So if engineering is responsible for turning off the lights and choosing the right size light bulb, then finance, procurement, and leadership, the strategic people, they must be the ones managing the relationship with the electric company. What's their main role here?
Their involvement is almost entirely focused on defining and maintaining the organization's portfolio of commitments. So we're talking about reserve instances, savings plans, and other long-term rate agreements. They're involved in securing the resources we need at a lower cost and, as we talked about, potentially with a lower carbon footprint, all while making sure these commitments meet the organization's business goals and its risk profile.
That's where the tension really shows up. I mean, engineering wants maximum flexibility and performance. Finance wants maximum rate discount and commitment. How do the sources suggest smoothing over that friction?
It comes down to shared incentives and shared data. Engineering needs to understand the financial impact of their choices. If they can commit to a certain workload size, finance can go lock in that better rate. But on the other side, finance needs to understand the technical risk. If they overcommit on rate agreements, they might, restrict engineering's ability to pivot or scale down. It's a constant handshake between technical execution and financial strategy, and it has to be centered on mutual accountability.
Okay, so that puts the spotlight right on the action plan. This is where the rubber meets the road. What's fascinating here is that the capabilities they define are really concrete, practical steps that organizations have to implement. Let's start with the rates, since that's the strategic function.
Rate optimization is absolutely foundational. I mean, look, if you use something inefficiently, a discount helps, but it doesn't fix the waste. But if you're efficient and you have a great rate, that's just massive value creation. So a key capability is being able to analyze and manage both spend-based commitments and resource-based commitments.
Wait, just for the listener who needs the cheat sheet, can you give us a quick conversational example of the difference between those two?
Absolutely. Think of it this way. A resource-based commitment is when you commit to using a specific type of resource, let's say a particular virtual machine size, for a year. You commit to the resource itself. A spend-based commitment is when you commit to spending a certain dollar amount over that same period, and you can use it on pretty much any resource type you want.
So the second one is much more flexible.
Much more flexible, which is why organizations need to manage a whole portfolio that balances both types.
That clarity helps a lot.
Okay, so finance and procurement are managing that portfolio to get the best rates. Now, what about the other side of the coin? The technical actions engineering takes.
This really boils down to two things: efficient design and effective governance. First, they have to focus on optimizing resource utilization and efficiency. This is your classic right-sizing, making sure a database isn't running on a server that could handle 10 times its load, or, scaling down dev environments over the weekend. Right-sizing seems so simple on paper, but I know from experience that engineers often push back. Why is it so hard in practice?
It's cultural, isn't it? Engineers are usually incentivized by uptime and performance, not by cost. So they default to padding capacity. A little extra compute is like cheap insurance against a massive outage that could cost the business millions.
Right. The fear of being under-provisioned drives them to over-provision.
It's the classic conflict.
So how does the framework address that cultural gap through policy?
By building both manual and automated policies to guide the teams, the goal isn't to force engineers to become auditors. The goal is to bake governance right into the pipeline. So an automated policy might be an alert that flags instances running below 10% CPU for a week, or a rule that just automatically shuts down non-production environments after business hours.
So enforcing good behavior through technology, which is always more effective than just sending out angry memos.
It is. And the most mature way to do this is to design your solutions with cost awareness from the very beginning. The framework calls this architecting for cloud. It means the architects aren't just thinking about performance and scalability. They are explicitly trying to maximize business value while hitting those technical goals. Cost becomes a design constraint, just like security or latency.
You mentioned the expanding measures of efficiency earlier, specifically carbon. That's a huge shift. It's a non-monetary metric that still requires resource optimization. Where does sustainability fit into this action plan?
Sustainability is no longer a fringe idea. It's a strategic metric now. A specific capability in this domain is all about establishing metrics and criteria for integrating sustainability goals into other FinOps capabilities.
So what does that look like in the real world? Does that mean choosing a cloud region that's less efficient if it runs on greener power?
Exactly. It might mean prioritizing cloud services that are just inherently more power efficient,
Yeah.
or choosing a region specifically because the grid there has a lower carbon intensity, even if that region costs a bit more or introduces a tiny bit of latency. This domain says that carbon footprint has to be a design input, right alongside cost and performance.
That is the ultimate definition of balancing that triple bottom line, isn't it? Forcing a decision based on multiple competing values.
Okay.
Okay, let's not forget the last action area, which is often this black hole of spending, software licensing.
Licensing is its own beast because it often involves these massive fixed cost long-term commitments that aren't in the cloud. Organizations have to develop specific ways to understand and optimize their use of software licenses and SaaS investments. If you bought a huge enterprise license for a database, and now 80% of your workloads use a modern cloud-native one, you've got these huge dark costs you have to manage.
It's basically the technical optimization of non-cloud assets. You have to optimize that usage just as carefully as you optimize a running EC2 instance.
Precisely.
Yeah.
And just to wrap up this whole action plan, the sources really emphasize the need for standardization. They reference leveraging the FOCS framework.
And for the listener, what is FOCS in this context?
FOCS provides a standardized language, a taxonomy for measuring efficiency KPIs. It just makes sure that whether you're talking about utilization, cost, or carbon metrics, everyone in engineering and finance is using the same definitions. Without that, you can't collaborate, and you certainly can't hold people accountable.
So what does this all mean for you, the listener, who's trying to implement or just understand this domain? We've covered the players, the actions, the metrics, but this domain is really a massive organizational health and accountability check.
It absolutely is. This domain is trying to answer some core questions that really define how mature and effective your organization actually is.
First, are engineering and product teams actually taking the initiative to be responsible? It has to be voluntary, ingrained in the design process, not something forced on them later.
Second, are we making the right choices for our architecture, system design, license use, and operations? This forces you to look at the whole tech stack and confirm that your decisions are creating business value, not just performance.
And third, are we matching our resource usage over time and, in the right location to the actual demand? If demand drops, are we scaling down? If we move a workload, did we clean up everything in the old place? It's the elastic health check.
And finally, the big one that ties it all together. Are we paying an appropriate amount in financial cost, carbon usage, and acceptable risk to meet our business goals? This is where that tension of the triple bottom line comes right back.
This discussion just confirms that central value equation. This whole domain is about making sure organizations use resources only when and where they provide the most value. It mandates that the impact of cost, including the chance to optimize rates, is factored into every resource decision, right alongside your architecture and your sustainability goals.
To summarize it, I'd say effective optimization requires this embedded integration of architectural design, strategic financial commitments, utilization policies, both manual and automated, and more sustainability metrics. It's a dynamic, multifaceted balancing act. It requires constant energy. And this deep dive really reveals that true optimization isn't just about finding the cheapest rate or cleaning up waste after it happens. It's about embedding cost, carbon impact, and risk tolerance directly into your system design choices before you even provision the resources. That's how you future-proof your efficiency. I'll leave you with this final thought to chew on. How might optimizing for carbon usage, a non-monetary metric, influence your next critical architecture choice, even if the purely financial cost of two options is exactly the same? If one option requires a region with 20% cleaner energy, does the long-term strategic value of hitting your sustainability goals outweigh the immediate financial desire for the cheapest rate today? That's where optimization gets really challenging, and I think where the most significant value is found.